Uh, okay. Hello. Hello. Mm, I think that um, we are live. Okay. So, so we were solving this question. Basically, what we needed to do was that no, we were actually solving this question. Okay. So what we needed to do is solve this question in offhand. Okay. So what I did was I created a difference array. Okay. So, but apparently, when I constructed the difference array, so I got this. Okay. Which is fine, perfectly fine. Um, According to my uh, calculations, we should be getting uh, 3, 4, minus 1, and again and minus 1 as an answer. But apparently, that's not the case. In fact, I am not updating my answer vector. Okay, so my difference array is spot on. So there's no doubt in that. Um, Let me see my map data structure. In my data structure, what I actually do is I calculate the number of elements of the first window of my difference array. Okay, so here my difference array was what? Uh, triple one minus one three. Okay, so first window, which is k minus one, which is actually two. That means this loop will run 0 and 1 only. Okay, so apparently I should have this in my map. Okay, I should have only this in my map. Let me just check real quick. See out MPP of one, and then I should output two. Okay, so that's fine too. Now I made a for loop which will go from I equal to 1 to n minus 1 minus k and I plus plus. Okay. So I am basically what I am doing is increasing the sliding window. So my map data structure basically I am leaving I minus 1 and I am capturing I plus k minus 1. Okay. That's essentially what I was doing here. It will go up to it will go up to what? I plus k minus 2, right? That means I plus k minus 1 should be the, I should take that. Okay, let's see, n minus 2 minus k and I plus k minus 1. So, um, n minus 3, weird. When my I would be last, that means n minus 2 minus k, then my last element to be added should be actually n minus 1 since difference array n minus 2 actually. Okay, since difference array just shrinks. So n minus 2 k minus 1. Hmm. So it is actually n minus 3, which shouldn't have been the case. Okay. So I think that it should be equal to, because when it will go up to that much amount. Okay. Um, I think when k minus 2, when I increased the 1, then okay, okay, I got it. I got it. N minus k, it should be n minus k. Hmm. Still, it's not updating my answer. Let's see what is actually happening in our map data structure. Okay, initially it was a minus 1, 1, 1, but what? 1? It shouldn't have been the case. Um, it's wrong, in fact. Okay, would be equal to um, max of 0, comma, mpp, uh, difference I minus 1 minus 1. That's should have been it. Okay, so something is wrong with it. Hmm, what we are missing? Okay, so I have won 2 times, which is good. Okay, then let's uh, see our difference error too. Okay, I have won 2 times, which is good. Then I increased the index. Okay, I increased the index, so it will go I plus 1 actually. Okay, so I think that here that's the problem. When I say 1, that means it means difference of 0. And when I say 1, it's 3, 4. So it's 3. But it shouldn't be 3 actually. It should be 2. Okay, so I think that that was the root of the problem. It should have been 2. Okay. And when I gets and I plus k minus 2 should be n minus 2 at the end of my whatever. So n minus k should be my last I. Let's just run it. Hmm. Okay, so 4 actually, in fact, got updated. Hmm. 4 got updated. It was 1, 2. Hmm. So why did this, why it didn't got updated? Hmm? I plus k minus 2 actually. because I'm adding that. Okay, now it's a 3. Hmm. Okay, so in first iteration, what happened here is that we added 3, which is good. Okay, we added 3. That's fairly well. Then we updated it. Uh, okay, -2 plus 1 actually. So it should be -1. Okay, and here if MPP of 1 is equal to k minus 1, so answer dot push back array, not array, nums of um, k minus 1. um, I think that should be enough. Okay, 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 we are almost done. Dot push back um, -1. I should also do answer dot push back -1. Okay, it worked. It worked. So see out. Let me see if I have removed all the see outs. Okay, there are a few handle statements which see out. This is here. I don't know what's calling. Okay, there it is. Hmm. Okay, this should work. Hmm. Wrong answer. The output should have been 1 and -1, but the expected one was 1 and okay, okay. So that's the base case actually. Edge case actually. If k equal to 1, just return return the original array. Okay, now submit. Hmm. I'm in fact at the edge. How others have solved. Okay, they used this. They instead of making a difference array, they used a variable called count. Hmm. Okay, so they used count, and what did they do with that? Okay, so they counted the number of um, pairs which are conjugative. Hmm. Okay, if this, then count plus plus, else count equal to 1. Okay, if count equal to k, result 0 equal to nums k minus 1. Mm, okay, I can't understand that. Mm, okay, next, let's do next question. This is apparently last question of this um pattern. It's an easy question. Mm, I don't really want to do the first one. Let's jump to second part of this. Um, there's no similar question. Let's just Google its second part. Leetcode. Okay. Hmm. That's an hard one. So we are given, okay, it's an OFN. We are expected to find OFN. Here we can use simple brute force. Okay, so let's let's try this first. Okay, so we are given an array nums of integer n and two integer k and x. Okay. If x sum of an array is calculated by following procedure, count the occurrences of all elements in the array. Keep only occurrence of top x most frequent elements. If two elements have the same number of occurrences, the element with bigger values is considered more frequent. Okay, so it's saying that I'm given an array called nums, which has an integer, and apart from this, I have two integer k and x. Okay, there's a sum called x sum. There's some property called x sum of an array calculated by the following procedure. Okay, count the occurrence of all elements in the array. Keep only occurrences of the top x most frequent elements. Okay. If two elements have the same number of occurrences, the element with bigger value is considered more frequent. Okay. Calculate the sum of resulting array. Note that if an array has less than x distinct elements, its x sum is sum of the array. Return an array answer of length n minus k plus 1, where answer of I is x sum of subarray this. Hmm. It's kind of implementation. In fact, it's quite implementation. I think. Let's try it. So apparently, I am given an given all these. Okay, return an integer array answer of length this, where answer of 5 is the x sum of subarray. Okay, so k is actually defining the window size. Okay, so let's suppose in this example 1 1 2 2 3 4 2 3. Uh, it's I plus k minus 1. That means I need to include six elements if I consider I to be zero indexed. Uh, 0, 1, 2, 3, 4, 5. So it will go up to 4. Now, 1 is occurring two times, 2 is occurring two times, 3 is occurring single time, 4 is occurring single time. Okay. Now I will take two of the most occurring elements, which is apparently 1 and 2, sum them, which will be 6. Okay, and I will put 6 as the 6 into my answer array. I will increase the window size. Okay, so I will update this map. I will update this map. Okay, I will update this map so it will be 1 and 1, then 2 and 2, 3 and 1 will not be affected at all. 4 and 1 will also be not be affected. Then whatever the element came at last will be updated. So since 2 came at last, so 2, 3. Okay, that's fairly fine. Now I need top two uh, most frequent elements. Okay, these collisions will give me troubles because I don't actually know how to handle them. I think I need to iterate manually through it. Hmm. And then I should output two. Okay, so that's fine too. Now I made a for loop which will be updated. Hmm. We okay. So what's our biggest challenge here? Handle the collisions. That's our biggest challenge in this question. Okay. So if I say one, okay. If I say one, two, three, three, one, and four, one, I can easily take out what's the maximum element. In fact, should I use multiset? Hmm? I think that multiset might have what I need. I think that I should use that. Uh, what's the topic called? Heaps priority queue. Yes. I think that we actually need some multi sets and something. Let's see the topic. Heaps and priority queue, right? Hmm. Can I take a hint? The run action function. Okay, really helpful. Ah, okay, so we need to handle collisions, but can priority queue actually handle collisions? Does it even take pair data? I don't think so. I don't think that it actually takes pair data. Ugh, I can't think of any solution. Let's see the solution. It's 100%. I think that we need um, you know, custom comparators to solve these problems. What it did was it used a function. What the fuck it is? Greater into is this C++? Okay, weird. Okay, that was definitely not easy. Okay, I know what the dynamic view is. I just need what is CMP. Okay, so that's some advanced stuff I don't know about. Okay, so we actually solved one only except one question we solved all of them. So I think that I it's safe to assume that we have uh, did this pattern. Okay, so I will just color it by green. Okay, we now let's go to trees. I don't think that I should really do trees because um I am kind of rusty in it, so I need to see stuff before attempting it. Okay, so let's end this Leetcode session. Maybe I will just move on to code forces, but there's half an hour left, so I don't think I can do much. Maybe I will do this level or traversal. Looks easy to be honest. Binary tree level order. Let's try it. Leetcode 102. Let's see. Okay, in fact I have did that, but I don't know how I did. Oh, in Python. In Python. Well, that's weird. Okay, so it's telling me that I have given a route. Return the level or traversal from left to right, level by level. Okay. You know what? I don't want to do it. Maybe I will do some DP or something. Should I do DP or not? How many questions did we do today? One, two, three, four. One, two, three. Three questions. Mm, okay, I think that's enough.